All right, so without using a calculator, what is 3 to negative second the same as, and how'd you figure that out? Without using a calculator. Do you remember what we discussed yesterday? What is 3 to negative second the same as?
We've slept since then.
All right, so yesterday we talked about the fact that when you have a negative exponent, you can make that exponent positive by doing what to the base? Taking the reciprocal. So the reciprocal of 3 is 1/3, and so now that's being raised to the positive second power. So what's 1/3 to the second? 1/3 times 1/3 is 1/9. So the answer is 1/9. Okay, so we talked about negative exponents yesterday. We had like 2 problems like that. Now it's going to take us with a question I'm about to ask you about exponential functions in a little while. So one more, let's look at this one. What if you had 3/4 to the negative third power? Without using the calculator, what is this equal to? How are you going to rewrite it? 4/3 to the positive third power. And so 4/3 means 4/3 times 4/3 times 4/3. So 4/3 to the third means 4/3 times 4/3 times 4/3. 4 times 4 is 16. 16 times 4 is, and that's where you all say 64. 3 times 3 is 9. 9 times 3 is, okay, at least you knew that one. So what's 3/4 to the negative third power equal to? 27. All right, now, if I have the function g of x equal 2 to the negative x. Now, on that in-class worksheet you had yesterday, I asked you whether that function was increasing or decreasing. And so, in this particular case, g of x, is this an increasing function or is this a decreasing function? And why? On your worksheet that you did yesterday in class, and all of you got it correctly, so I'm not understanding why you can't tell me that one. Why is it decreasing? Because yesterday we said if the base is bigger than 1, what's your function doing? Increasing. Well, what's the base here? What's the base here? 2. So is it increasing? The negative exponent has something to do with it. Why do you think I talked about these 2 things right here? So if I'm going to make that exponent positive x, then how do I write the 2? 1/2. So this is 1/2 to the x. And now you're going to tell me it's what kind of function?
Decreasing.
Decreasing. This number is less than 1. So g of x is a decreasing function. All right. So there are 2 ways that you can graph this. Now we're going to graph this. So let's graph g of x. So a couple of ways you can do it now. You can use 2 to the negative x, or you can use what? 1/2 to the x. They're both the same graph. They're both equivalent. Those are both equivalent. This negative exponent, to make it positive exponent, I take the reciprocal of the base. They're both equivalent, so the graph will be the same. So if you do, let's say you want to graph this one, the one that says 2 to the negative x, we use the t-table. Remember that? What's the horizontal asymptote? Y equals 0. That's your horizontal asymptote. Which happens to be which axis? The x-axis. once we found the horizontal asymptote, what was the other thing we had to find?
Oh, the y-intercept.
The y-intercept. And how do you find the y-intercept?
Plug in 0 for x.
Right. So you're always going to have a y-intercept because what's the domain? What's the domain of an exponential? It's all real numbers, negative to infinity. And so zero's in here, right? Isn't x equals 0 in here? So in a graph, when x is 0, that happens to be which intercept? The y-intercept. So you're always going to have a y-intercept. You're not always going to have an x-intercept. We saw that in many of the situations yesterday. If the graph is above or below this x-axis, it's not going to cross it. So if x is 0, I can either use this one or this one. It does not matter. What's 2 to the negative 0 power?
Negative 1.
It's 2 to the 0, which is what? 1. Or if you want to use 1/2 to the 0, what's 1/2 to the 0? It's 1. So your y-intercept is 0, 1. So you plot that point. And now you know that the graph is located where? Above or below the horizontal asymptote? Above. So right away, you can tell me the range without even knowing, without even graphing it, just knowing that it's above, right? And how do you know that it's above the horizontal just by looking at your function? We talked about that a couple of times yesterday and the day before. How do you know that the graph is going to be above the horizontal? Guys, you know it's on your next test, right? The number in front of the base is what is what's that sign in front of 2 to the negative x or 1/2 to the x? It's positive. Remember, it's going to be below if there's a reflection. There's a reflection if there was what in front of this 2 to the negative x? A negative. All right, so that's on your third test, guys. It's on your third test. Graphing these. All right, so the graph, just without even knowing what the y-intercept is, you know that the graph is above the horizontal because there's not a reflection. And so if it's above the horizontal, then the range is from that horizontal to infinity. So it's from 0 to infinity. All right, now I need about 2 more points. So if I look at the y-intercept, let's let x be 1. Let's see what happens if x is 1. If x is 1, I get 2 to the negative 1. Now, for those of you that don't remember anything about negative exponents, you're going to put this in your calculator. What's 2 to the negative 1 in your calculator? Which is a half, right? Which is 1/2. Which you knew it had to be a half because when we rewrote it as 1/2 to the x power. So if I use this one here, that's 1/2 to the first power, which is 1/2. So in either case, you get the same y value. You get 1/2.